so when we get to here, we can use the segment addition postulate to turn these into AC and BD, which is our final goal. Okay, so we've got BC plus CD equals BD. That's that one. All right. So if you think about it, we've got AB plus BC. Isn't that right here? AB plus BC. Okay. And it's equal to AC. Then we've got BC plus CD. That's right there. And it's equal to BD. So I like Mrs. Weaver's analogy about the basketball. If these are equal, that means they're the same position. Like you've got two guards here and two forwards. They're the same. So that means I can change one in for the other one. Okay, I can sub in a different player. So I'm going to take out AB plus BC and substitute in AC. I'm going to take out BC plus CD here and substitute in BD. Okay, so now based on the substitution property, I've turned the substitution property and the segment addition postulate. I've taken both of these and turned them into AC equals BD. Does that make sense?
Can somebody explain what you just said? So it doesn't make sense. So go ahead, give it a whirl.
If you add the two together, you can switch it out for what they equal. Like you can switch them out for what they equal.
Right. You can switch out either of these two for the other one. Yep, absolutely. Okay. So these two come together to form this one. Okay. Now remember though, we're trying to be congruent here, not equal. So how do I change equal to congruent again? Patricia? I know, it feels on my hand. Yeah. Yeah. To switch from congruent to equal or equal to congruent. Remember we've used this one twice just in this proof. We use it all the time. All right? To switch from equal to congruent or congruent to equal, we use a definition of congruent. All right. All right, so let's try one more here. Did you get one last time?
I mean, we can try, yeah.
Yeah? Is it better than...
the circles. Do you think you guys can fill it in and do the arrows? Sometimes I think setting up the circles is the harder part.
Okay, so let's talk about the proof for just a second. It says if I know that 2 and 4 are equal, I want to prove that 1 and 3 are equal. So the proof says, well, what kind of angles are these? Linear pairs. Very good. Wow.
Nobody ever gets that.
I know. Those are linear pairs, which means they are supplementary and they equal 180. So if, let's say this number 4 is 50, okay? If 4 is 50, how much is angle 3? 130, because they'd have to add up to be 180, okay? If these two are equal, doesn't that mean this one also has to be 50? So that means angle 1 would be what? 130 as well. So this is basically what the proof is saying. If these two are equal and they're supplementary to the same angles, then these two have to be equal too. Okay, that's basically what the proof is saying. All right, so let's say I've got, oops, come here. Okay, so I've got these circles.
So does everybody know what's going to go inside the circles? What goes in the circles on a proof like this? The steps or the justifications? Kendall? The steps. So inside all those circles are going to be a step that's already laid out in that two-column proof. Does everybody understand that? And then underneath or next to the circle is where you're going to write the justification. So what's going to go in that first box?
Okay. All right, so to put these in order. What do we need to do here? Jessica, what order would they, where would these last three statements go? And what would go in this circle? What's first in our proof? Well, we already got that one, so the next one will be this one, right? Angle 1 and 2 are a linear pair. What's going to come next? Right. Right. Angle 2 and angle 1 and 2 are supplementary, 3 and 4 are supplementary. And then what? What is that? Something. What's that symbol mean? Help her out. Congruent. That little twirly thing on top of the equal sign means congruent. Okay? It's pictures are congruent and numbers are equal. Alright? And since these are angles, not measures of angles, they'd be congruent instead of equal. Alright? Alright, so let's put arrows in there. Does the fact that angle 2 is congruent to angle 4 directly tell me that these are a linear pair? No, they really don't have anything to do with each other, so I'm not going to put an arrow between these. How about the fact that they're a linear pair? Does that lead me to the fact that they're supplementary? Yeah, so I am going to put an arrow there. Okay? How about why angle 1 is congruent to angle 3? Does that have something to do with them being supplementary? Remember how we talked about it? Angle 4 and angle 2 are equal, and because they're a linear pair, they're supplementary. That means V1 and 3 have to be equal too. So that's going to be this one and that one. Both of those are going to make angle 1 congruent to angle 3. And then the fact that angle 1 is congruent to angle 3, will that lead me directly to the measure of angle 1 equals the measure of angle 3? Should I put an arrow between those? Okay. And Lauren, why? Let's put some reasons in here. And remember, we can use the proof. Why? What's the reason for this one? Good. Okay. What's the reason for this one? Right. A definition of linear pair. And then? Theorem? Theorem, yep. Okay? Right. Congruent supplement theorem. And finally, good. Remember, that's the one that toggles between equal and congruent. Okay? So that's how you would draw a flowchart. So the only difference between this and this is the things that lead into the next thing have to be connected with arrows. All right? So that's flowcharts. Let's talk a little bit about paragraphs because this is other people's favorite. Let's move this up a little bit to begin. There we go. Okay, a paragraph proof works again just like a two-column proof, except it's written just in long form. Okay, but it still has all the statements, all the reasons. Okay, so let's see if we can go through and circle all the reasons. Harrison, give me one reason in this proof.
Remember, reasons are going to be a definition, postulate, property, or theorem. So just go through, or it's going to be given.
So we're looking for words like definition, theorem, postulate, given. Right.
Definition.
definition of vertical angles. That's one of our reasons. What's another reason?
Kit.
Kit.
The first one's given.
Yeah, good. Given. Tim? Good. And last but not least, Audrey? Congruent supplement, right? It has the word theorem with it. So those are going to be my reasons. Okay? What are going to be my statements? Jake, give me one. Good. Angle 1 and angle 3 are vertical angles. Give me another statement. Ben?
One and two are a linear pair.
Good. 1 and 2 are a linear pair. And 3 and 4 are a linear pair too, right? That's probably all one. Okay? Another one. Right. And 2 and 3 are supplementary, right? I think they're doing these together, so we're going to keep going here. And so that's 3, so we need one more. Last but not least. Last but not least. The last statement. Exactly. Okay? So there's all my statements. They're in order. All I have to do is pull them off and put them in my chart. Okay? Because a paragraph proof, you'll notice it reads like you would read if you were going to go through there. It just has connecting words like therefore, so, like we are given that angle 1 and angle 2 are vertical angles, so they are formed by intersecting lines based on the definition of vertical angles. Therefore, angle 1 and angle 2 are linear by the linear pair theorem. So it just has like connecting words. It's just basically reading through the 2-column proof and adding connecting words. Okay? So we would start by saying angle 1 and angle 3 are vertical angles. Okay? By what? Why? Why are they vertical angles? Given. Good. Okay? What's the next statement? Javier, what will come next? Are right. 1 and 2 and 2 and 3 are a linear pair. And why? What does it say? Why are they a linear pair? What's the reason for that one statement? Yeah, definition of vertical angles. Isn't that the one that's circled next to the statement? Okay, what's the next statement?
What's the next thing underlined, Hannah?
Right. 1 and 2 and 2 and 3 are supplementary. Why? Andrew? Why would they be supplementary? What does it say? Exactly. Linear pair theorem. So be careful because you notice on that one, the reason came first in the sentence. They were just, when they were writing the paragraph, it just sounded better. So they made that one come first. All right. And then our last statement. What comes last?
What are you trying to prove here? What always comes last? Kendall?
Right. Angle 1 Nope.
That's what you're trying to prove.
Right. Congruent supplement theorem. And remember, the congruent supplement theorem again means that if two angles are congruent or are complementary to the same angle, they're congruent to each other. That's on our list over there. Congruent complement. No.